we are in taking across, okay, or in getting the genotypes of the parents and the offspring. Okay, so let's move on to the modifier genes. We are through with the lethal genes. You are already familiar with that one. That in the presence of those genes, that would actually give a harmful effect on the individual. Okay, so the next one is the modifier gene. So when you say modifier gene from the word itself, modify, it actually alters the expression of the trait. So modifier is pertinent. So if this one is actually present in the gene pairs, you have here the alteration of the expression of their trait. Okay. So in order to analyze a modifier gene or the presence of a modifier gene, we usually consider this dihybrid cross. Okay? So if you would notice in the dihybrid cross, the so-called dihybrid, because we are actually pertaining to two different traits. Okay? So when you say dihybrid, you actually pertain to two different traits. And this is usually composed of two gene pairs. Okay? How many alleles do you have here? How many alleles? For each gene pair, you actually compose of how many alleles? 2. Therefore, if you have two gene pairs here, how many alleles are we going to consider? Okay, so you have here 4 alleles. Okay? So this is on the usual dihybrid cross. In the presence of a modifier gene, in the presence of a modifier gene, if this is actually being represented by these organisms, heterozygous for A and D, okay, you are actually pertaining for two different traits. For example, this one pertains to the eye color, and this one pertains to the height of the organism. Okay? This is on the usual cross or on the normal cross. In the presence of a modifier gene, what you have to consider here is that even though it is actually composed of a dihybrid cross or an organism which contains two different alleles or two different gene pairs, have here A and B, okay, you will only have or you will only came up with one trait. Okay? Why? It is because the other one, if you're going to look at this one, if this is for the eye color, for example, this one would serve as a modifier gene because this would actually enhance, instead of having another trait to consider, it would only enhance or not allow the expression of the first gene. Did you get that? So instead of this one controlling the second trait, which is the height of the organism, for example, okay, this would actually enhance or not allow the expression of the first trait. Did you get that? So that's why in the presence of the modifier gene, instead of considering two different traits, you are only considering one trait. But if you're going to look at the gene pairs, they are actually composed of how many gene pairs? 2. They are composed of 2 gene pairs, and they are usually composed of 4 alleles. Did you get that? Questions so far? Do you see the difference? Okay. So let's move on. So I want to show you some of the modifier genes that can be found on the different traits. Okay, so there are so many modifier genes. I think we have 20. But for the purposes of our discussion, we're going to delve only with the 5 modifier genes. So just to show you the existence of these genes. Okay, so the first one in the modifier, we call this one as the novel phenotype. Okay, so please take a look at this one. new phenotypes result from the interaction between the dominant as well as the homozygous. Okay? This one is actually been seen in the comb shape of the poultry. What is the Tagalog term for comb shape? What is a comb shape? Palong. Okay? Palong. So we're going to look on the shape of the palong for the different roosters that can be found in the poultry. Okay? So before, they used to differentiate the comb shape into two. You have the rose type in the presence of a dominant R, and in the presence of the P, or the dominant P rather, you have the P type. Okay? And in the presence of the recessive alleles for those gene pairs, you have here the phenotype which is single. Okay? Do you see that? So in the presence of R, you have the rose type. In the presence of P, you have the P type. In the homozygous condition of both, you have the single type. Okay? So what they actually do is to try to breed or mate a purebred for rose. Purebred because you have here the homozygous dominant R in the presence of a recessive P. Okay? This one is the P type because you have a homozygous recessive for R but homozygous dominant for P. Okay? So they try to cross the rose type and the P type. But what we found out eventually is that if you're going to look at this one, you will be forming a heterozygous organism. Tama ba? Okay. In the heterozygous organism, in the presence of both dominant R and dominant P, no one wins. But a new phenotype was actually being evolved. Okay? So instead of having the rose type or the P type, because that is the indication of the dominant alleles, instead of having that, you have another formation of phenotype which is walnut. Okay? That is actually due to the interaction of both dominant alleles from each of the gene pair. Okay? So when they try to cross this F1 progenys, okay, you are already familiar with this. If you cross the two heterozygous organisms, you always get a phenotypic ratio of 9:3:3:1. So you have to memorize all of these things because you are always expecting this one in a dihybrid cross. Only it's for you to give the phenotype for each of the progenies. Okay? So this one is already being expected. You have a 9:3:3:1 ratio. Okay? But based on the cross, it is you are the one who will determine what will be the phenotype of the following progenies. Did you get that? Okay. So please memorize the 9, which contains the dominant for the first gene pair and another dominant for the second gene pair. Did you get that? The 3, which contains the dominant allele from the first gene pair, but it would actually contain homozygous recessive for the next gene pair. Did you get that? Okay. 3, for the first gene pair, you have a homozygous recessive, and you have here the dominant allele from the second gene pair. Okay. And the last one, yung 1 nyo, would be a homozygous condition for all the gene pairs. Okay, naiintindihan po. Okay, with regards to this one, so if you're going to have here both dominant R and P, based from the cross, you will be getting a walnut. Okay? If you're going to have here a dominant R, but recessive for P, you have the rose type. Recessive for R, but dominant for P, you will get the P type. And homozygous condition for both, you will have the single. What is the difference between this one and the normal dihybrid cross that you get last time? Last time, how many traits do you consider? Okay, you actually have 2. So aside from the comb shape that you were expecting, you have another trait to consider. But it's because of the presence of the modifier gene, you will only have one trait to consider, and that is the comb shape. Did you get that? Last time, you have the color of the seed and the texture of the seed. So you have two phenotypes. But in this regard, because of the presence of the modifier gene called the novel phenotype, you will only be considering one specific trait. But please take note, you have to remember also the phenotypic ratio, which is 9:3:3:1. Did you get that? Okay, let's move on.